What do you mean by Gauss law? What do you mean by Gauss law? Yes. Total flux over closed surface is equal to the charge enclosed, right? Total flux over any closed surface is equal to the charge enclosed. See others, how much of you have learned about it? We have crossed that Gauss law in the first unit. So clear. So we have del dot D is equal to rho V. This is another form of Gauss law. Del dot D is equal to rho V. Right? Where V is called as the flux density and rho V is called as the of E. D in terms of any time you come to same question. What is D in terms of E?
Epsilon naught
D is equal to
epsilon naught
epsilon naught into E, or I can write it as epsilon into E. Is it not? Epsilon into E. Okay. So E del dot D in the place of D I am going to substitute as epsilon E is equal to rho V. Can you do that? D is equal to epsilon into E. So del dot D is equal to del dot epsilon into E is equal to rho V. So what is E? E is equal to anybody? E is equal to minus del V. Take down. E is equal to minus del V. So we have del dot epsilon into minus del V is equal to rho V. Is it clear? Del dot epsilon into in the place of V and substituting it as minus del V is equal to rho V. So we have it as epsilon into del dot del V. Can I write like that? Minus epsilon into del dot del V is equal to rho V. Okay? So clear? Right? So from this one we have del dot del V is equal to rho V divided by epsilon minus rho V divided by epsilon, or it can be written as del square V is equal to rho V divided by epsilon. So clear? Del square V is equal to minus rho V divided by epsilon. This is called as Poisson's equation. This is called as Poisson's equation. Take it up. If they ask me a question, derive Laplace and Poisson's equation. So this is called as, what is that? Poisson's equation. Okay? Okay? Next one. In certain regions, we can say that this rho is equal to 0. Where in the case of dielectric, rho V is equal to 0. In the case of, take it out, next point. In case of dielectric or a two dielectric medium, volume charge density is equal to 0 or rho V is equal to 0. So we have del square V is equal to 0. Del square V is equal to 0. So clear? This equation is called as Laplace form of equation, or it is called as Laplace equation. It is called as Laplace equation. Del square is called as the Laplacian operator of V. Laplacian operator of V. Del square is called as the Laplacian operator of V. Is it clear? So this is about Laplace and Poisson's equation. Clear, ma'am? Okay, right. Now we'll see about del square value in different coordinate system. Clear? Is it clear? What we have arrived at? What is Poisson's equation? What is Poisson's equation? Del square V is equal to rho V by minus rho V by epsilon is called as a Poisson's equation, and Laplace equation is del square V is equal to 0. What they may ask you in the problem is, they may ask you the derivation of this, or they may give you one equation and they will ask you whether this equation is satisfying Laplace equation. So clear? They will be giving you an equation and they will be asking you to find out whether the particular equation is satisfying the Laplace equation. has to be equated and found out the value for del square d. You have to find out for del square d and check whether it is equal to 0. If it is equal to 0, it satisfies the Laplace equation. Is it clear now? If del square d value is equal to 0, then it means that it satisfies Laplace equation. If not, you have to just tell that it is not satisfying Laplace equation. Very easy question, but people will not be attending this question because they do not know how to solve. I will solve you now the steps. 3 different ordinates: Cartesian, cylindrical and spherical. How we are going to find out the Laplace operator? We are going to apply it in the equation. That's it. Clear? Right. Now we'll go for the next one. Del squared operation for different coordinate systems. Take it out. Del squared operation in different coordinate systems. Del squared operation in different coordinate systems. So, del t can be written as dou by dou x of ax vector plus dou by dou y of ay vector plus dou by dou z of az vector. What we have to find? We have to find del square d. That is del dot del v. We have to find what is that? Del dot del v. Right? This del operator is nothing but dou by dou x, dou by dou y, then dou by dou z. That's it. Okay. So del dot dou v, then del v will be equal to what did we have here? Dou square. Very good. Can I go to the final expression? Okay. So what is that? Dou square v by dou x square times of ax vector plus dou square v divided by dou y square into ay vector plus dou square v by dou z of ax. That's it. Sorry, I forgot to put here. Okay, clear now? Clear? So this is del square d for a Cartesian coordinate system. Cartesian coordinate system. Okay? Now we'll move on to cylindrical coordinate system. Cylindrical coordinate system. It is given by del square d is equal to 1 by r into dou by dou r of r into dou v by dou r, right, plus 1 by r square into dou square r divided by dou theta square plus dou theta square dou phi square. Cylindrical r phi is what we get here, phi square. Okay, plus dou square v by dou z square is equal to 0. This is the expression for cylindrical coordinate system. You have to by heart that. Otherwise, you have to go with your basic formula and derive. Just by heart that equation. Okay, what is that? Tell me. 1 by r into dou by dou r of r into dou v by dou r plus 1 by r square into dou square v. Dou square v by dou phi square plus dou square v by dou z square is equal to 0. Right? This is for which system? Cylindrical. Right? Cylindrical coordinate system. Next one. For spherical, take down. For spherical, del square v is equal to 1 by r square into dou by dou r of r square dou v by dou r plus 1 by r square sin theta into dou by dou theta of sin theta dou v by dou theta. As you know, for spherical it is r theta phi, right? So 1 by r square sin square theta dou by dou square d by dou phi square is equal to 0. This is for spherical. Okay. Now we are going to apply it in the equation to find out whether it is satisfying the Laplace. This equation, what is switching off? Now switch off this light. Switch off this light. Why it is not black?
சுத்தமா தெரியல.
Now, no?
Okay.
Okay, take it up. 1 by r square into dou square d by dou phi square is equal to 0. Clear, students? Clear? These two equations you have to by heart. First equation is very easy. But second and third you have to by heart. Then only you can solve the expression and you can find out whether it is satisfying Laplace. Okay? Take it faster. Copy it, cylindrical. I have gone for cylindrical and spherical I have completed. We are still in Cartesian. Move the side. Move the side. What is that? We are checking in. Keep your book inside. Keep your book inside. Clear? Again. Right. Now let's solve problem theta. Determine whether or not the potential field satisfies the Laplace equation. Determine whether or not the potential field satisfies the Laplace equation. V is equal to x squared minus y squared plus z squared. Okay, so in Cartesian or it is cylindrical. First one is x squared minus y squared plus z squared. First one. Second, you have it as v is equal to r cos phi plus z. Third one, you have it as v is equal to r cos theta plus phi. Three expressions are given here and they are asking to check whether it is satisfying Laplace equation. What you have to do? Have to check whether it is satisfying Laplace equation. What I have to do?
Del
Del
square
square d has to be found out. Okay, and we have to check whether it is equal to
0.
0. If it is equal to 0, it is satisfying the Laplace. If not, it is not satisfying. Okay, first one let us find out for this. So what is this? Del square d is equal to tell me.
Dou square v
Dou square by
square.
dou x square of x square minus y square plus z square plus dou square by dou y square of x square minus y square plus z square plus dou square by dou z square of x square minus y square plus z square. We have to find it out and check whether it is equal to 0. Please tell me what will be the first expression. Dou square by dou x square of this term. Dou by dou x of this term. 2x. Right. I'll write one more step. Dou by dou x of 2x. The next step. Dou by dou x of 2x is 2. Right? Then plus here. Dou by dou y of, right now, dou square by dou y square can be written as dou by dou y into dou by dou y of the next. So first dou by dou y, then we can have having it into minus 2y plus dou by dou z of 2z. Okay? So here what we have here? Minus 2 plus 2. So this 2 is getting cancelled 2. So what we have got? Del square b is equal to 0. Is it equal to 0? No. So del square b is not equal to 0. So this equation does not satisfy the Laplace equation. Clear? Clear, students? It is not satisfying Laplace equation. Why I have taken this expression? Why not the second one and the third It is a partition form. Okay, now. Fast. The next one. Next expression. What is the next one, Vikarma? V is equal to, what is the next one? V is equal to R cos phi plus Z. So for this, what can I take? Cylindrical. So what is the expression for cylindrical? We got it in notebook just now. What is that?
1 by R.
1 by R into 1 by R into dou by dou R of 1 by R into dou by dou R of R into dou V by dou R plus 1 by R square into dou square V by dou phi square plus dou square V by dou S square. So first what I do is that inside terms we take, simplify that and then we go with the final expression. Okay, ma? So what is the inside term we have got? Dou V by dou R. Right? Should I write the expression?
Second one.
Second one, the inside part of the bracket we write it separately and then we go and substitute in the main equation. Okay, what are the terms inside the bracket?
R into
R into dou V by dou R. R we have it as later and we find out dou V by dou R. Okay, ma? R finally substituting and into. What is that? Dou V by dou R we have to calculate. What is dou V by dou R in this equation?
cos phi.
Dou by dou R of
Cos phi.
R cos phi plus Z. What is this? What? Tell me.
Cos phi.
Cos phi. It is equal to cos phi. Alright? Right? R term alone will be writing, other terms will make it as 0. Right? Next, dou V by dou phi. Dou V by dou phi of R cos phi plus Z. So what will be the term inside? Cos phi. Minus sign. So we add the minus R sin phi. Is it not? Okay? Right. The third term. Clear up? Following? Right. The last term. What we have?
No, take differential.
Yes, no?
Dou square V by dou.
Oh, it is
Second
squared.
derivative.
So dou by dou phi of?
Dou square by dou phi square.
Again, I
Second
have
answer and not differential.
Next step I write. Then I write to the next step. Dou square by dou phi. So what will be the
Minus R cos phi.
it will be minus. Sin will become cos phi. So again there is a minus. So it is minus R
Cos phi.
cos phi. Okay. Minus R cos phi. I have included in the last step. We will go here. Right. Fine. Okay. The next one.
Dou square V
Dou
by
square.
dou Z square.
Dou square V divided by
Dou Z
dou
square.
is the square. Dou is it or dou is the square?
Dou Z square.
Dou is it, right?
Dou Z square.
Dou is the square. Okay. First I find out for dou is it and then we go for the next step. Okay. So dou by dou is it of
The 1 to 1.
dou V by dou is it. That is equal to dou by dou is it of R cos phi plus Z. What is this term? 1. Right? It is equal to 1. The next step will become
0.
0. Because constant differentiation it becomes 0, right? Constant if you differentiate again it becomes 0. The final answer will be 0. Clear? Now we'll go with the main equation and substitute. Finish with this. Clear with the steps. Should I explain it again? Right, take it out. Take it faster. Check whether it is satisfying. What it should satisfy? Third row, what it should satisfy? Third row, boys, we want to answer. What it should satisfy? Very good. It should satisfy Laplace equation. Very good. What is the condition for satisfying the Laplace equation? Which is equal to 0? Huh? Which equation? Del square t is equal to 0. T is the class. Del square t is equal to 0. Here it comes. Finish? The last page, when you got the answers were returning from for me, but now coming to the third bit, I don't get any answers. See how they implement it? Right. If you want to learn, you have to be ideal. Right? You need not have your friends. That is not required. If you want to grow up or go to greater heights, you need not have friends. Go to the last bit and give me answer. That will be fine. Okay, take it. Now, we'll go to the final expression. Yes, tell me now. Del square root is equal to 1 by r. Answer. We have already found out dou by dou r.
Cos phi.
1 by r into
Cos phi.
cos phi. Right?
Ma'am, dou by dou r. 1 by r into dou by dou r.
1 by r into dou by dou r of r into dou by dou r. So what will be happening there? Again there one r and r will be getting cancelled. The final expression is 1 by r cos phi. Alright? And going to the final. Okay ma'am? Cancel all the r terms, you will be getting this. Okay? Then second term. Second term minus simplify it in ma minus again there
Minus
1 by r squared, right?
Minus cos phi into dou by dou r.
Minus cos phi
Into dou by dou r.
simplify it in final answer will be minus cos phi by r. Check. Yes. Yeah, that's all the same. Listen here now. What is that? 1 by r into dou by dou r of r into dou v by dou r. Is it not? Is it not? Right, is it? Listen, this is equal to 1 by r into, right? This dou v by dou r, what we get? Dou v by dou r.
Cos phi.
Cos phi r. Right? So this is cos phi. So r cos phi. Right? Okay? So here dou by dou r of r cos phi. Okay? Now simplify this.
Cos
1 by r cos phi. I thought you come with the final step. That's it. Answer is 1 by r into cos phi. Correct? Okay. Correct. Still not interesting. Dou v by dou r is cos phi. This r is here. Dou by dou r of this term will become cos phi. Already 1 by r was there. Okay. Right. Finish. When you solve, you have doubts. When you take it directly from the book, you never have doubts. Correct? Go for the next one. Right, the next one, 1 by r square dou square d by dou phi square. That is equal to 1 by r square of dou by dou phi of minus r sin phi. I think that we have already solved. So it is minus r cos phi divided by r square. This r and r will be getting cancelled. So finally I have minus cos phi divided by r. Clear? Okay. The next term. What is the next term? Dou square d by dou z square. Already we have integrated and equal to 0. Okay? Right. So finally I am adding all the terms. Get it as 1 by r cos phi minus 1 by r cos phi plus 0. This term and this term is getting cancelled. Finally we have got del square is equal to del square is equal to 0. So del square Finish? B is equal to R cos theta plus phi. B is equal to R cos theta plus phi. Shall we have this as homework for you? Right? I'll give the final answer. Can you check it out? 2 I have solved, no more. 1 you can take it as a homework. Take it out. B is equal to R cos theta plus phi. Play solve. Third one. Third one, take it as a homework. The answer is the answer for the third one also, it satisfies Laplace equation. Check it out, huh? Can you solve? Shall I go to the next step? Next topic. Okay, Amma? The third one, the same way, is a spherical coordinate system. You have to check the spherical coordinate system and equate and check whether del square V is equal to 0. Right? If it is 0, it satisfies the Laplace equation. The third equation is satisfying, so check whether you are getting the answer. Okay, leave half page for that. Leave half page for that. We are going to do and check whether it is satisfying Laplace equation. Okay, now the last topic of your unit. Take it out. Capacitance using Laplace equation. Capacitance using Laplace equation. And I think the unit is over. Capacitance of a parallel plate capacitor using capacitance of a parallel plate capacitor using Laplace equation. Using Laplace equation. So you are listening, huh? We are going to consider the capacitance of a parallel plate capacitor. So what do you mean by capacitor? We know that two parallel plates separated by means of a air as a medium or any dielectric, right? So that is called as a capacitor. So here I am going to consider our inner circuit with the radius A and the outer circuit with the radius of B. Okay? And the outer circle is grounded to ground. So it is also shown in a figure. At R is equal to B, at R is equal to B, the potential B is equal to 0. Potential B is equal to 0. Why it is 0?
Ground.
Because it is grounded. Okay? Because it is grounded. Okay? Now, E will be only E. Capital E will be in the radial direction. Capital B will be in the radial direction. And B will be changing in radial direction. B will be changing in radial direction. B will be changing in radial direction. So according to Laplace equation we have del square B is equal to 0. which means that radial direction, so it is 1 by r square into dou by dou r of r square into dou v by dou r is equal to 0. Radial direction, so 1 by r square into dou by dou r of r square into dou v by dou r. 1 by r square cannot be equal to 0, so only term that can be equal to 0 is Mr. 1 by r square can be equal to 0. 1 by r square. Is the value equal to 0? No. So only term that can be equal to 0 is dou by dou r of r square dou v by dou r is equal to 0. Again. Yes or no? Why any doubt? 1 by r square that will have some constant value. So it will never be equal to 0. Correct? 1 by 5 square, 1 by 10 square will never be equal to 0. So that cannot be equal to 0. So what you done that will become 0. Okay. So r square dou v by dou r is equal to r square dou v by dou r is equal to 0 plus the constant c1 that is equal to c1. Right? So from that I say that dou v by dou r is equal to dou v by dou r is equal to c1 by r square. c1 by r square. Now please follow. R square into dou v by dou r is equal to 0 plus c1. Okay, right? So we have to have the term dou v by dou r. So dou v by dou r is equal to c1 divided by r square. Okay, pick it up. So that is equal to c1 r to the power of minus 2. c1 r to the power of minus 2. Please take it faster. c1 r to the power of minus 2. So what is mean of this? Again I can integrate c1 by r square or c1 r to the power of minus 2 into dou r. Otherwise, dou v by dou r is there. I want to be, what I have to do? Dou v by dou r is there. I want v. How do I do that? Integrate. Right? A basic concept. Dou v by dou r is the v we have to